Okay, this is try number 2 for recording. I hope this records this time. Alright, so let's flip back over here. Day 1, week 8. We went over this in class with fractions. So 4/9 plus 2/9 is 6/9. Use the model. We did that. We proved that 6/9 and 2/3 are equivalent. Next one, we are writing digit times the place value. So on the bottom, you should have done 3 times 10 plus 8 times 1 plus 8 times 1/10 plus 5 times 1/100th plus 7 times 1,000th. Remember, you could use either one. Okay, next one, solve using order of operations. You should have had 29. For this one, you should get 25. Are they the same? No, because you changed the way you grouped or you changed the way the operations were done. Okay, number 4, notice the pattern. If I divide 180 by 10, I get 18 groups. If I divide 180 by 1, I would get 180 groups because there would only be 1 in each group. If I were to divide by 1/10, it's the same as multiplying by 10. So how many would I get? I would get 1,800 groups. Okay, I'm getting smaller amount, so my number gets larger, but the amount that each person gets smaller. Okay, number 8, day 2. 6/12 plus 11/12 should be 17/12. Or 1 and 5/12. So that would mean I would have a whole bar and 5/12 also. So I can record it in both ways, 17/12 or 1 and 5/12. Are they the same? Yes, they're the same. They're equivalent. Okay, Juan and Layla are saving money to make from walking their dogs. Layla has $37.82 less than Juan, and we see Juan's amount. So what do? We subtract it. Now, I will caution you, you have to line up your decimals when subtracting. You line them up, you bring it down, and then you forget it, and you just subtract like you normally do. Okay, so he should have Layla should have $380.55. With multiplying decimals, remember it's the same. You can use whatever method of multiplication you want. You just have to count how many decimal places in the entire equation. There are 2 decimal places, so I start behind the number and I slide in 2 times. That shows me that this is 17 and 55/100ths. This only has 1 decimal place, so I would start behind and push in 1 time. That would give me 175 and 5/10ths. Makes sense? Okay, what do you notice about the 2 equations and the 2 products? You should notice that the numbers are the same, but they're worth more because of one is worth more than the other because of the placement of the decimal. Okay, number 4 is an order of operations. You should have solved the grouping first, then you divide, then you multiply, then you subtract and add from left to right. And adding came first, then you subtract. You should have 14. Week 3, rounding to the nearest whole number. So this rounds to 8. This should round to 9 because of this 7 here tells it to push up. This rounds to 8 because the 4 tells the 8 to stay the same. And because this is just 8 on its own, it's just 8. Add it up, I should get 33. Now I stack every single one of these numbers and I annex zeros behind the 7 and behind the 8 so that when I line it up, my decimals are lined up, and that should give me 33 and 14/100ths. Number 2, guys, if you do not stack these decimals and you do not annex a 0, you will get the wrong answer for the exact. For my estimate, I'm rounding to the nearest 10, so here's the tens place. Looking at the tens place, this tells me to add, looking at the ones place, it tells me to add 1 to the tens. So this becomes 310. This turns to 0, that turns to 0. Okay, 154 and 99/100ths. So that 4 tells me to keep the 5 the same. The 4 turns to a 0, so does that. So I could leave that as 310 minus 150. It gives me 160. I don't need these zeros. I just put them over there so you could see them. Exact, I had to stack, I had to annex, and then I had to regroup. If I don't put a 0 here and I get a 9, it's going to throw the whole answer off. The answer is 153 and 71/100ths. Number 3, distributive property. I'm going to distribute 34 to 30 and 4. Remember, I'm going to have to add. Now I multiply 30 times 7/10 and 4 times 7/10. That gives me 21 on this side and 2 8/10 on that side. I line up my decimals and then add. So that's an 8 here, 3 and 2. That gives me 23 8/10. Notice the pattern. 10 to the power of 1 is the same as 10 because it's just 10 one time. So that's 10. 10 to the power of 2 is 10 times itself. So that would be 100. 10 to the power of 3 is 10 times itself, which would be 1,000. So let's do that with 3. 3 to the power of 1 is 3. 3 to the power of 2 is 9. 3 to the power of 3 is 27. 3 times 3 is 9 times 3 is 27. Now I'm going to stretch my thinking and add it into an equation. 3 to the power of 2 is 9. Rewrite. Now I saw from left to right, 9 minus 7 is 2. Bring down my plus 5. 2 plus 5 is 7. So my answer should be 7. Write equivalent fractions for 8/12. I could divide or multiply to change these. So let's divide. I'm just going to divide by 2. 8 divided by 2 is 4. 12 divided by 2 is 6. Now I'm going to divide by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. I can even take an equivalent fraction and make another equivalent fraction. So I'm going to take this and I'm going to multiply it times 5. 2 times 5 is 10. 3 times 5 is 15. Next one. And yes, these are equivalent still to 8/12. Okay, next one. It says James added the above amounts and he got 105 and 81/100ths as a sum. When adding, what mistake did he probably make? Well, let's look. I didn't get 105. I got 971 and 7/100ths. So what did he probably do? He didn't line up his decimals correctly. The brown rug covers 721 and 3/10 square centimeters, and the green rug covers 376 and 28/100 centimeters. How much more area does the brown? Oh, how much more? That tells me to subtract. So I'm going to take my larger number, subtract from the smaller. I lined up my decimals. I annexed a 0 because when I'm subtracting, if I don't do that, the whole thing is wrong. If I have an 8 here, it's wrong. Why? Because I ended up borrowing a 10 from here. And this became 2/10. This became 1/100th. So now I've got 345 and 2/100 square centimeters more. You should notice a pattern here. If I multiply times 1/10, I'm sliding this number over once. This one gets by 100, so I slide that 357 over twice. If this is times 1,000, I slide it 3 times. Another way of saying this is divide it by 10, divided by 100, divided by 1,000. The digits shift by a place value. Okay, use what you do know about multiplication to determine the following would have more, a quotient of more than 100. So first of all, it has to fit. It has to be something that you could multiply by 100. This would be less than 100 because if I multiply that by 100, I get 1,700, which is too big. Same thing here, 2,900 would be too big. This would be exact, so that doesn't work. And this would be slightly under, so that would mean that 3,617 would work when I multiply 35 times 100. So this is the only one that could work. Okay, list the next 5 prime numbers. Remember, prime numbers have to be divisible by more than 1 in itself. So, I'm sorry, they can only be divisible by 1 in itself. So it'll be 11, 13, 17, 19, 23, and 29. Have a good evening, guys.